Hi everyone and welcome back. In this video, we're going to explore ratios using lots of visuals, structure and clear examples to help develop conceptual understanding. We will cover what ratios are and what we can use them for, what other math skills we need to work with ratios, and then some examples. So talking through how the language in a ratio question affects exactly what we do. So first, what are ratios? Well, we use ratios to show how much of one thing there is compared to another. So for example, let's imagine mixing squash with water in the ratio 1:4. That means for every 1 part squash, you add 4 parts water. We can visualize that by looking at the glass on the screen. Here we've got one section squash, so 1 part squash, and the next 4 sections or 4 parts are water. Ratios work a little differently from fractions and percentages, which compare a part to the whole. So if we use this example, we could say that 1/5, 1 out of 5 parts of the whole drink is squash, or we could say 80% of it is water. But ratios keep the focus on comparing the 2 parts directly. So some examples of where we use ratios in real life. Often they're used in baking, so recipes, cooking, maps and scale models. You'll likely see ratios as well. Financial planning, things like ratio analysis and design, photography and design. So here's some common examples of where ratios are used for different kind of screen dimensions. Let's look at one way that ratios can be used. And as I just mentioned, recipes are quite a common area. So we will use a recipe for this example. To make shortbread, you use sugar, butter and flour in the ratio 1:2:3. To make this kind of a bit clearer, we might use a sort of something visual like this. I've just used boxes to show I've got 1 part sugar to 2 parts butter to 3 parts flour. And let's kind of look at some of these ingredients and compare them. Think about what the ratios would be and what that means. So first we've got sugar to butter. So we have to think really carefully about the order. So sugar is first, then butter. So sugar is 1 part, butter is 2 parts. So the ratio is 1:2. What does that actually mean? Well, if we're cooking, it means that we would use twice as much butter as sugar to keep this recipe turning into nice shortbread rather than something that is too liquidy or too solid. Butter to sugar, we're doing it sort of from the other angle. So butter's first this time, so it would be 2:1. And that means use half as much sugar as butter. And if we looked at sugar to flour, sugar is first, so that's going to be 1:3. And that means we use 3 times as much flour as sugar. This is really helpful because we can apply it to a situation like when you're cooking and you've only got a certain amount of one ingredient and you need to think, right, have I got enough of the other ingredients to make this recipe properly? So if we've got 60 grams of sugar, how much butter and flour would we need to use? Well, we already know that the ratio of sugar to butter is 1:2, so we need twice the amount of butter. So 60 times 2 is 120, and we know that we need 3 times as much flour as sugar, so that will be 60 times 3, which is 180. So then we can go and check and see if we have enough of each ingredient. So before we get into some questions, let's just talk about what skills we need for working with ratios. So there are 3 really important skills. The first one is division, and we need this to break amounts down into equal parts. I will link my video on division strategies here. Next, multiplication, which lets you scale those parts up to find the final answer. But last, definitely not least, is reading and comprehension. Ratio problems can be really tricky because often key details are hidden in the wording. So if you misread the question or misinterpret it, the maths won't help. So we'll be using lots of structure and visuals to make sure we represent the question correctly. I will also link my video on worded questions here. It's got lots of ideas on how visualization can help make sense of worded questions. In the next part of the video, we're going to look at 3 worded ratio questions. And we'll look at the first two side by side so that you can see how the language in the question tells us how to choose our method. And as always, we'll use lots of visuals and structure to help. Okay, so the first question, Maria and John share some money in the ratio 3:2. John has £14. How much does Maria have? First, let's bring in that structure. So Maria is first and she has 3 parts. I've got 3 boxes for her. And then John has 2 parts, 2 boxes. Separate those with the ratio notation. And now we can go to the information in the question. It says John has £14. That means that we're going to share that £14 equally across John's boxes, and he has 2. So we're going to do 14 divided by 2, which is 7. That means £7 can go in each of those 2 boxes, and it can also go in the 3 remaining boxes. And we can now go back to the question, how much does Maria have? She's got 3 lots of £7, which gives us £21. Moving on to the next question. Anna is making a drink which uses orange juice, pineapple juice, and lemonade in the ratio 3:1:4. She makes 1 litre of the drink. How much of each ingredient did she use? Again, let's bring in some visual structure. So we've got 3 parts are orange juice, we've got 1 part is pineapple juice, and then the last 4 parts are lemonade. There we go. The next thing to look at is what information we're given. We're told that she makes 1 litre of the drink. Now, 1 can be quite tricky to divide up, so you might find it easier to think of it in terms of millilitres instead. 1 litre is the same as 1,000 millilitres. Personally, I just find it easier to use that, so I'm going to use 1,000 millilitres instead. And we're told that she makes 1 litre of the drink. So that's the whole drink, including all of the parts, which means that we're going to divide 1,000 up between all of the boxes, and there are 8 in total. So 1,000 divided by 8 we could do in a bus stop, possibly like this one. So here we're just working that out, and we get 125, which means 125 will go in each box. There we go, and we can now start working out how much of each ingredient she used. So orange juice is 3 lots of 125, which is 375. Pineapple juice is nice and easy because it's just 1 lot of 125. And then for lemonade, we could do 4 lots of 125, or we could double it and double it again to get 500 millilitres. And there we have it. So hopefully you can just see how using that extra bit of structure can just help us make sure that we're dividing up by the correct number, the numbers are going in the right place. We're going to look at one last question. Family A and Family B split their dinner bill in the ratio 5:3. Family A paid £32 more than Family B. What was the total bill? Okay, this might be quite hard to think about, just given the words. So again, let's bring in some structure. So we've got Family A are first, and they've got 5 parts from the ratio. Then Family B are second, and they've got 3 parts in the ratio. Now let's go to the information in the question. Family A paid £32 more than Family B. So what we need to think about here is we need to compare the parts in the ratio and look at how many more parts Family A has than Family B. And if we compare, Family A have 2 more parts. So they've got 5 parts, Family B has 3, so Family A has 2 more parts. And that means that the extra money must account for those extra 2 parts. So the £32 accounts for those extra 2 parts. So what we'll do is we'll divide 32 into 2, which gives us 16 in each box. Now we know what goes in each box, we can fill in the rest of the boxes with £16. There we go. And now we can go back to the question, which says what was the total bill? So we're going to be looking at the whole diagram now. And there are 8 parts in total, so 8 lots of 16, which gives us £128. Now that we've looked at 3 examples, I just want to do a quick kind of recap and reflect, just to look at the differences. In the first question, we were told that John has £14, so we divided that £14 across John's boxes, and there were 2 of them. In the second example, we were told that Anna made 1 litre of the whole drink. So we divided 1 litre or 1,000 millilitres across all of the boxes. And in the third question, we were told that family A paid £32 more than family B. So we split that money across some of family A's boxes or the extra boxes that family A had. Using something simple, just like boxes, to represent the parts in a ratio can really help ensure that we're dividing up by the correct number. It helps us organise kind of what goes where or what belongs to who in the question. The boxes don't need to be perfect, just having that extra structure can make it easier to connect the question to the calculations. Following on from those 3 examples, and just as a kind of practice activity, you could have a go at these 3 questions here, not necessarily needing to do all of the division and scaling up, but just laying out the kind of visual structure with the boxes and deciding whether the amount would be shared between all of the boxes or just some. So pause the video, have a go, and then play when you're ready for the answers. Okay, in the first question, we've got the ratio 2 to 3 for Charlene and Danielle. So the visual structure might look something like that. We're told that Danielle gets £25 more than Charlene. So that means the £25 is going to go into any extra boxes that Danielle has. She only has 1 extra, so the £25 would go in there. For the second question, we have ratio 4 to 5, and that's Simon and Luca. We're told that they make £450 in total. That means that the £450 will be divided between all of the boxes, and there are 9 in total. And then for the last one, we've got the ratio 3 to 4, 3 parts of Greek yogurt to 4 parts of self-raising flour. And we're told that 160 grams of self-raising flour is used, which means that 160 would be shared between the 4 boxes which represent flour. So hopefully you managed to get through that okay, and hopefully this extra structure has been helpful for you solving these problems. That brings us to the end of this video on understanding ratios. We've looked at what ratios are and why we use them, what other skills we need to work with them, and looked at how we can bring in additional visual structure to support and organise our working out with some examples. I hope you found it useful. If you did, please give the video a thumbs up and consider subscribing for notifications on my next tutorials. Thank you so much for watching, and see you in the next video. Bye.